Let's have a closer look at our process named controller. We know that it will have to be able to receive the input from the motion sensor or from the magnetic sensor, process it, and send the signal to alarm unit and the camera to activate them. Then it will have to receive video data from the camera. So we see that the software part of our program will have to accomplish at least 3 tasks: read input, produce a command, and process the video recording. Such computations are usually done by threads. There can be many different ways to design this. For example, we can make one thread do all the work, or we can have up to 6 or more separate threads to receive inputs and talk to each device. Depending on the non-functional requirements of the system, a simpler or a more complex design can be proposed. But for the purpose of this tutorial, we will have 4 threads. Let's add one thread which will wait for the event from the motion sensor. Second thread will wait for the event from the magnetic alarm sensor. Both threads will talk to the third thread, which will send control signals to camera and alarm unit. The last thread will receive, filter, and process the video stream data. Now, as you remember, every time we added a new component of our system in the past, we would add it to the top-level view of the system implementation, security system with devices. However, this time, these threads are subcomponents of our process controller, and that's why we are going to add them in our specific implementation of this process. Use the word subcomponents and specify each subcomponent's name inside of this implementation, its type, and name outside of this implementation. It is always good to use the graphical representation of the AADL model in OSAID to check if everything is going smoothly. For example, even though we've added threads to the process, they don't show up in the graphical view. The problem is that we added threads to a particular process implementation, but that process implementation was never added as a part of our system. Only the process type was, so we can easily fix it and add it. Now we see the threads inside of the process, but we need to establish the connections between the threads and the ports. Let's establish communication from the thread which processes input from the motion sensor to the in-event port of the controller process, which receives this input. To do so, we'll add an in-event port in the thread component type declaration. Then we'll specify the connection between the thread's in-event port and the process's in-event port in the process's implementation. Now you can see that the connection between the process and its thread has been established. Let's do the same for the thread which processes input from the magnetic sensor. Both threads will talk to the control rules thread, so we'll need to add out event ports in them. Then we'll have to add 2 in-event ports in the control rules thread. Add corresponding connections to the process's implementation. To allow the control rules thread send the signal to alarm unit and camera, let's also connect it to the outside world. Add 2 out event ports and specify the connections between the thread's out event ports and the corresponding out event ports of the process. Now the only thing left to do is to connect the thread which takes care of the video stream to the controller processes in data port. All the necessary connections between the threads and their process have been established. In the next video, we'll see how to schedule these threads and how to conduct the first analysis of our system.